Okay, projectile type 2. I don't know why it's so weird looking on the screen. Okay, whatever. A stone is whipped off horizontally the side of a cliff and lands 45 meters. Oh, that's over 3 stories, right? 4 stories, right? In the water from the base of the cliff. All right. Well, what's going on? Landed 45 meters from the base of the. All right. So basically, a stone's coming off. It's going. It's not high. It's not high. Oh, the height of the cliff is 44. So the height is 44 meters. Poor choice. And it lands. The range of it landing in the water is 45 meters. What else do we know? Anything else? Jeepers. It feels like I didn't give you enough information. I wonder if I did. I'll have to figure this one out. So what do we know? Just do that for the next 2 weeks. There's no acceleration of that rock in the horizontal x-axis. It only occurs as it's going down. It goes down, it goes faster, 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 faster. This arrow always stays the same length throughout. I don't know what that is. Let's put in negative 9.8 here in meters per second squared. This arrow goes, smaller, larger, and then really large going down. If you look, small arrow, a little larger arrow, and then, like that's almost no arrow right there. So it's just kind of showing you how it's progressing. Arrows stay the same horizontally. Arrows increase going down. All right, let's put ounce ready now. This, the base is 45. The height is 44. What else do I know? Yeah. All right, we also know that you need 3 things here, and this is really kind of painful. So I don't know what the velocity is like before it gets thrown off. I just know how it kind of lands. So I'm going to start over here. So start on this side. Start here. Start at the Y. Because the first thing I want to do is you want to try to find the time. But we got to fill this whole chart out. So let's just go right here. We know that vertically, it's just like dropping. Once it leaves the cliff or your hand or whatever, it starts to drop. So now that's kind of easy because this helps us solve for problems. Got 3 things, you can solve for everything. It's kind of amazing how this works. All right, let's see. Now I don't have time, so skip that one, and we'll go right to here. V final squared equals V initial squared plus 2AD. This is 0, so I'm not even going to be writing that on my next one. I'm just going to put V final squared equals 2 times negative 9.8. Oh, negative. Oopsie daisy. Oh, man, pick myself a bouquet of oopsie daisies today. Whew. All right, now multiplying 2 negative numbers is a positive. So I'll throw that in my calculator. 2 times 9.8 times 44. 862.4 equals my V final squared. Square root that. Square root. Gives me a single V final. Now I'm going to do the square root. Second x squared. That gives me that symbol. Then I have a stored answer, and I hit second answer equals 29.4 meters per second. All right, so I put that in my calculator. Oh, yeah, and then we're going to choose negative. Choose it. Remember, that's plus or minus. Plus or minus comes out of the square root. Choose down. Because it could be plus or minus, we choose the negative. So 29.4 meters per second. Now I got to solve for time. Oh, this is the y-axis. Y-axis. We're still doing the y-axis. This y-axis stuff. I'm going to do the time. You got a couple to choose from. I like to choose the easiest one. I think that one's too complicated. I mean, it's not that bad because this goes to 0. I'm just going to choose the simple one. V final equals V initial plus AT. That's 0. My V final is negative 29.4 equals negative 9.8 T. What's this doing to the T? That's multiplying it. See the symbol between these two things is multiplication. Go to the opposite. Divide by negative 0.8. These lovely things cancel out. Bye. Then I'm left with T is equal to, I think I have the 29. I gotta divide by 9.8. Divide by 9.8. Oh, I'm just gonna round to the whole number. Oh yeah, it does say on that. I don't know if it says in yours. It's like 2.99. Which is basically, T is, it's basically 3 seconds. It's supposed to be approximately equal to 3 seconds. I'm just putting a 3 seconds up there to make my life easier. All right. Now, same. It's the universal. It falls through the air at the same time. So as it goes, when you look at just the x-axis and just the y-axis, this is the x, right? And the y, it's the same time. Same. It's no big deal. Well, I'll help you out here a lot. What? Now you can find for V final. No, it's right there. So these are all zeros because the A is 0. Because of this, like this is cool. Now you got to do, we're going to look at the x-axis. So we're going to do x-axis stuff. The only equation that's like worth anything, because this is like, yeah, okay. This is like, yeah, square it, yeah, okay. This is the only one that's worth it. It's D equals V initial T plus 1/2 AT squared. I don't even bother writing this normally. I'll just goof it around. Because A is 0. Bye-bye. So D equals VT. Put in your 45. Put in your V, which you don't know. Put in your 3 seconds. Got to get V by itself. Since the 3 is multiplying, this is multiplication. That's multiplication. Divide by 3 both sides. That goes to 1. I have V equals 45 divided by 3. Hopefully you know that's 15. Let's just check it. 45 divided by 3. Oh, yeah, good. My husband will be so proud. 15, what's my unit? Meters per second equals V. I like to write the V on the other side, but whatever. V equals 15 meters per second. Hey, stop digging on my couch, dog. Oh, gosh. All right, she stopped. Yeah, my nickname for my dog should be Adam. I love you. Hey, Joey. Yeah, Adam ruins everything. I don't know if you ever watch that stuff. All right, so now that's the x-axis, right? That's the x-axis. So I'll put 15 meters per second. Now, does it change its velocity? It's flying through the air. That velocity arrow stays the same. All right. Do this a little fast. All right, now I gotta do the last part. What's the impact? So there's like stone goes over a cliff. Oh, here's your cliff. Right? Here's the stone. Crashes into the ground. Right here, you have 2 velocities. You have the velocity you're looking for the V final. You have the velocity going down, which is negative 29.4, right here. And then you have the velocity going in the x-axis. The other velocity is this one, which is like half. 15 meters per second. You got to combine them. So I like drag this one over. And then I make my resultant. Here's my resultant. I got to combine that one and that one. That's my resultant velocity. Resultant velocity. Go to English class, guys, because, man, I can't spell. Oof. I can, but it takes me forever. And you got to find the impact angle. It looks like it goes straight down, but whatever. That's like not really a good impact angle looking, whatever. But so put that in. So you have to do. Let's do the first part. So the first part, you have this 15, and then you have this negative 29.4. We're gonna keep everything positive, just because we're just trying to find this length. We don't really need to find out what quadrant it is. I'm getting rid of the negative. I'm trying to find that. And that's a squared plus b squared equals c squared. C squared equals a squared plus b squared. C squared equals 15 squared plus 29.4 squared. C squared equals, so 15. See the calculator. Whatever. Do you need to see me? I don't know. 15 squared plus 29.4 squared. Remember, it's like the squared button is right there. Equals, I'm going to write that down, 1089.36. Technically, this is a meter squared second squared. And then you square root both sides. C is second square root. So I hit the second and then that little symbol right here, the x squared, because that gives me the square root symbol. And then it has a memory second answer. It's down here, that one. Gives me the answer. And C is 33 meters per second. So that's what this number would be. 33 point, no, it's there. So 33 meters per second. There's your math work. So that number right there, that actually combined velocity is 33 meters per second. Now we gotta find the impact angle. Oh gosh, Mrs. Nicole, here we go. Gotta find this. The impact angle. So the impact angle, kind of already explained it, is going to be the tan of opposite over adjacent. So I'm looking for this angle. And the opposite number is the 29 and the adjacent is 15. These are the lengths. So I put in theta inverse tan, because that does the opposite. So I got rid of the tan on this side, put it on this side. And this is going to be 29.4 divided by 15. Put that in. Let's make sure you guys know how to do this one. Clear it. Second inverse tan right there. Give me that button. You have to hit the tan, and you hit the second button, it gives you the stuff on top. Then I put the number 29.4 divided by 15. There you go. The angle is 62.9. I'm not even say 63. Theta is approximately 63 degrees. So that angle right here, 63 degrees. Done. Woohoo!